Hello, today's lesson is Identifying Functions Part 2. And yesterday we talked about how to identify functions in graphs and ordered pairs and in tables. And today we're going to focus on equations. But before we do, you might notice that these have exponents on them, these equations that we're going to deal with. And so we're going to just do a very cursory review of that, and we haven't spent any time on it this year. So we're just going to briefly have just kind of a mini lesson on exponents. So if I had the number 3 and I raised it to the second power, this would be 3 raised to the second power, or when we use the exponent of 2, we call this 3 squared. That means that we're taking 3 times 3, and the result, or if we evaluate it, it would end up being 9. We could also have taken 3 raised to the fourth power, and that means 3 times 3 times 3 times 3. Now, that would not be 12. It's not 3 plus 3 plus 3 plus 3, but 3 times 3 would be 9. 9 times 3 would be, 27, and 27 times 3 would be 81. So when I have an exponent, and you're hearing exponential growth, you might have heard that phrase before, it means that it grows quite larger quickly when we're multiplying them. So for our purposes today, we're going to focus on squares, 5 raised to the second power, which means 5 times 5, which is 25. But we can also multiply negatives. So I could have negative 3 squared, and that also means negative 3 times negative 3. And if you recall, when I have a negative and I multiply it by negative, I get a positive. So negative 3 squared also equals positive 9, and that's going to have significance in a few minutes. And same with 5 squared. I could take negative 5 and I could square it, and that means negative 5 times negative 5, and same thing, when we multiply two negatives, we get a positive. So you're noticing that the input right now that I'm putting in, 3, gave me a positive 9, but if I also have a negative 3, it gives me a positive 9. So just like other things, in math, if I add, the inverse is subtracting, and if I divide, the inverse is multiplying. Well, squares also have an inverse. So if I wanted to find the square root, or unsquare 9, well, the base of it was positive 3. So unsquaring, or finding the square root of 9, would be 3. But also, if I unsquared or found the square root of 9, the base could also be negative 3. So they sometimes write this. They might write positive and negative square root of 9, which means the positive square root would be 3 and the negative square root would be negative 3. We could also do that for our other two examples. If I found the square root of 25, well, it would be 5, or the square root of 25 could also be negative 5. So if I wrote the square root of 25, positive and negative version, I would get 5, or it would be negative 5. And that's going to have significance now for our lesson. So let's move on to our lesson. So an equation represents a function if every input, x, only results in one output for y. And it suggests that we substitute various input values to see if an equation represents a function. So we're going to test different input values to see if the following equations represent a function. So I see y equals x squared. And so I'm going to build just a little mini table. And I'm going to write x, and I'm going to write y. Now notice that y, when I have to get the output of y, but my input, I'm going to square it. So this is what I'm going to do with the inputs. So if I use the number 2, well, I have to square it, and it's going to give me back the y value. So 2 times 2 would be 4. So if my input is 2, I'm going to get back 4. If my input was 3, well, I'm going to square it, and my output is going to be 9. If my input, let's go ahead and use a negative number. If I have -7 as my input, so -7, and by the way, when you use a negative number, you have to enclose it in parentheses and then put the exponent. So negative times -7 is going to be 49. So as we're testing these, each one of these x values has a 1 output, okay? So 2 has just 1 output of 4, 3 has just 1 output of 9. Well, let's see if we can. -7 had 1 output of 49. What if I would have used +7? So let's try that. If I use +7, the output is also 49. But if you recall, in the range, it's okay for the numbers to be repeated because they're paired up. This 49 is paired up with 7, and this 49 is paired up with -7. These, the domain members, these are the numbers that we cannot have, we cannot see twice paired up with different numbers. So -7 is paired up with 49, and +7 is paired up with 49, but each one of the domain members are unique. Each one of these members are unique, so we're in good shape. So this is, yes, this is a function. And it's because every input has one unique or results in only one output value. So now let's go on to the next equation. As we test this equation, we're going to go ahead and build a table again. And I can see that the y this time is squared, not the x. So I'm going to have an input, but in my table, I need the y to not be squared. I need my input and output to not be squared. So I'm going to choose, because I see this square, I'm going to choose a perfect square. I'm going to choose 4. So if I put 4 for the x's in this equation, and it says that that equals y squared, well, they're equal to each other, so y squared must be 4. But I don't want y squared in my table, I want y. So that means I have to find the square root. But if you recall, the square roots are positive and negative. So when I go to find this square root, I'm going to get a positive square root and a negative square root. So if I unsquare 4, I'm going to get a +2. 2 times 2 is 4. And I'm also going to get a -2, which means that my input of 4 has 2 square roots, and it has 2 outputs. And if you recall, the domain in a function cannot be doubled twice. This 4 has 2 outputs, so this is not a function. So I'm just going to let you know, rule of thumb, because I know this is complex and we haven't really had enough time to really build this and work on this. For our purposes right now, and later on you're going to explore this in depth in your 8th grade year, but right now, if you see y squared, it's a good rule of thumb. This is not a function. Okay. It's okay to have x squared, but it's not okay to have y squared. When you see that, that's not a function. So what I'd like you to do now, based on page 6 and page 7, would you see if you can tackle 9 through 14? And then I will post the key, but it also not only mentions say yes or no, but it asks you to please justify your answer. Say why you're telling me it's a function, yes it's a function, or no it's a function. Thanks so much and have a good afternoon.